And so in this last section of lecture, we're going to talk through some complex experimental designs. Specifically, we're going to talk about two different kinds of designs. And so we're going to have at the end of today, we're going to have two basic kinds of experimental designs and two more complex kinds of designs. So I'm going to talk you through these two different kinds of more complex design. And then we're actually going to look a little bit in how to interpret some of the results of these kinds of designs, because specifically the second of these complex experimental designs have some particular things that we'll want to keep in mind about how we interpret and how we express these kinds of results. And so our first kind of complex experimental design is when we're just going to add more levels of our independent variable. And I alluded to this earlier when we talked about basic experimental design. I said our most basic experimental design is going to be that post-test only design, and we're going to just have two levels of our independent variable. We need at least two levels because we know that variables have to vary. There has to be more than one level of our variables. And so in this case, though, we're still going to have one independent variable, and now we're going to have 3+ levels. So we could have 3 levels, 4 levels, 5 levels, however many that we might need in our particular study. We're still only going to have one independent variable, though, only one variable that we're manipulating. Remember, the independent variable is the variable that's being manipulated by the experimenter. And similar to what we saw before in our post-test only design, we're going to only have one dependent variable. So one independent variable with 3 or more levels and one dependent variable. And this is going to be measured once. And so this design is going to look very, very similar to what we discussed before, but we can compare more groups and get more nuanced information. And so again, this is what our post-test only design looked like before, and we can imagine just tacking on one more group, one more arrow from participants there to a third level of our independent variable. And this could be a second experimental group. We might even think of these as different versions of these groups. So we talked about, actually last lecture, we talked about the idea of maybe if we're looking at something like the placebo effect, we can have a version of our experiment where we have one group that gets nothing, one group that gets a placebo, and another group that gets our medicine. And so by having these 3 groups, we get to kind of be able to tease apart the effect of the medicine versus the effect of the placebo and this placebo effect. And so this is what one of these 3-level kinds of designs might look like. We might also have a version of this where maybe we're testing the strength of our manipulation. We talked about that last lecture as well. And so maybe we are testing our placebo, and maybe that's our control group, and we're testing 2 dosages of the same drug. So we have a placebo group, a low dose group, and a high dose group. And again, we have these 3 or more levels of our single independent variable, and we're measuring our dependent variable just once after that our participants encounter that independent variable. And so this is our first more complex experimental design. The second kind of complex experimental design is when we start adding independent variables. So now so over here, we saw that we added a level to our independent variable. And here we're actually going to add more independent variables. And now we see that this figure here, this table that we're looking at, looks very, very different. And so here we're going to have 2 or more independent variables. Each of them have to have at least 2 levels. They can have more, but they each have to have at least 2 levels. Again, variables vary. But we have 2 or more independent variables. And again, we can have more. We can have 3, we can have 4. We're going to, in most of the examples that we'll talk about, probably all of the examples we'll talk about, we're going to keep this to 2 independent variables with at least 2 levels. But again, we can have more. And in this case, we're still going to have one dependent variable measured once. And so this is what this kind of design is going to look like. And for the record, we can have multiple dependent variables. We haven't seen that in any of the designs that we've talked about here. In our studies, we can certainly have more than one dependent variable. Usually we would be maybe analyzing that separately. So we're not going to really be thinking about that. Generally, we're going to be thinking about how many independent variables do we have and how many levels of that independent variable do we have. And that's what we're going to focus on. We're going to think about how many times we measure our dependent variable, but not necessarily how many dependent variables that we have. And so, for instance, we can think about, with this complex experimental design with more independent variables, 2 independent variables, I can think about maybe mood and exercise. And so I can manipulate how much people exercise, and I can manipulate if they exercise with a friend or not. And in this case, I'd be measuring mood. So my study is looking at this relationship maybe between mood and exercise, how exercise impacts mood. And again, I have 2 independent variables. The first, how much people exercise, and the second, if they exercise with a friend or not. And so we can think that this is then going to combine in a couple of different ways. And so someone can exercise a little bit. And so maybe we have people exercising either once a week or 3 times a week, and they're exercising with or without a friend. And so that would give us what we would call a 2-by-2 design. And we would be able to see in this case that all levels of each independent variable are going to be combined with all the levels of the other independent variable or variables. And again, the simplest version of this, 2 or more, at least 2 independent variables, and each with at least 2 levels, we have a 2-by-2, what we call a factorial design. And so it's spelled out as 2x2, but we pronounce it as 2-by-2. And the first number that we see, that first 2, indicates how many levels our first independent variable has. And in this case, we have 2. Exercise once a week or exercise 3 times a week. And that second 2 indicates the number of levels of our second independent variable. And this also has 2 levels: exercise with a friend, exercise without a friend. And again, this then gives us essentially 4 total groups. We have a situation where someone is exercising once a week without a friend, someone who is exercising 3 times a week without a friend, someone's exercising 1 time a week with a friend, and someone's exercising 3 times a week with a friend. And then we're going to compare all 4 of those groups and measuring, using some measurement of mood. In the diagram that's on here, we see a situation where people are looking at different how social this person is that's with them, as well as how much food the person with them eat. And in this case, this is Confederate. We mentioned Confederates earlier in the semester. Confederate is someone who's working with the experimenter. And so in this case, the experimenter was either sociable or unsociable. They were friendly and talkative or not. And that person ate either a small amount of candy that was left on this particular table in this situational experiment, or they ate a lot of the candy out of that bowl. And then the measurement was how much did the participants eat. And so we have these 4 different conditions. Again, sociable with low food intake, sociable with high food intake, unsociable, low food intake, unsociable, high food intake. And that would also be a 2-by-2 factorial design, where the first independent variable is how sociable the person is with 2 levels, sociable and unsociable. And the second variable is food intake with 2 levels, low and high. And so we could have more independent variables. And so if we're doing this, we're going to add on another by with another number. And so that represents how many levels that independent variable has. So if we add on a third variable with a third independent variable with 2 levels, we can have a 2-by-2-by-2 factorial design. Again, in most of the examples that we'll talk about in class, we're going to focus on just having 2 independent variables, even though we can have more. But we can think about having more levels of those. So if, for instance, our first independent variable had 3 levels, we can have a 3-by-2 design or a 2-by-3 design. Again, we're going to think about those numbers are going to represent how many levels each of our independent variables have. And in a 2x3 design, we would have 6 groups. In a 3x3 design, we'd have 9 groups. And so we're going to be thinking about kind of how we would build out that chart to kind of show all the different groups of our design based on how many variables, how many independent variables, how many levels rather of our first independent variable and our second independent variable that we have. And so when we're thinking about factorial designs, these particular kinds of designs are interesting in terms of how we can interpret these studies. And so there's 2 different kinds of results that we get from a factorial design. And so because we have more than one independent variable, essentially what happens is that we can look at the result for just one of those variables, just the other of those variables, or both of them together. And so when we look at the effect of each independent variable on its own, just one at a time, we call those kinds of results mean effects. And when we look at the effect of one independent variable, when we look at these together, how they impact each other essentially, the effect of one independent variable is different at different levels of the other independent variable. We'll make sure that that makes a little more sense in a couple of minutes. That's when we talk about interaction effects. And so when we think about the main effects are simple. These are just exactly what we would expect if we only had one independent variable that we were working with in our study. The effect of that just one independent variable on its own, the other independent variable on its own. But the interaction effect is when the effect of one independent variable essentially depends on a particular level of the other independent variable. And we can only get these this interaction information when we test 2 independent variables at the same time. We can't get this if we're looking at one independent variable in one study and one in another. It doesn't work that way. And these designs can use one independent variable, and they can include as a second independent variable a participant variable. And so we can think of those participant variables that get included as kind of okay in the criteria for these kinds of variables. Those are kind of like those ex post facto designs that we talked about back when we were talking about the different kinds of studies. And so those weren't true experiments, but those ex post facto designs had to do with things like gender, age, these variables that often look like independent variables, but the experimenter can't or doesn't actually manipulate. And so with our factorial designs, we can have one true independent variable that gets manipulated, and the other can be just a participant variable. And again, these interaction effects, we're going to look at kind of how these work together. So maybe one independent variable differs, and maybe we're looking at men and women, or maybe we're looking at older adults and younger adults. And maybe there's a difference between how on one of our variables, there's a difference depending on the other variable. So men are acting differently in one area, with regard to one variable than the other, and women are also differing in a different way. And so I'm going to show you, it's a little bit easier to see when we look at this in a graph form. And so I'm going to show you what these results look like. And so this would be one example of a study. And so this is just looking at a simple study where we're looking at 2 different conditions with silence or people or television on in the background. Participants are reading something, and we're looking to see how much they comprehend in each of these situations. But we also have some of this participant information, one of these participant variables, whether people are an extrovert or an introvert. And we've thrown this variable into the mix. So we have 2 different variables here. We can see 2 of those variables on the bottom axis here, on the x-axis, with silence as one variable, television is the other. So we have 2 variables for our first, 2 levels, of our first independent variable. And for our second independent variable, we also have two levels, and these are shown in the blue and the orange, so two colors for the two other levels of these variables, marking extroverts and introverts. And we can see this pattern where introverts are doing better, their comprehension is higher in the silence condition, but the introverts are doing worse in the television condition. But the extroverts are doing about the same, a little worse in the television condition, but not what we would call statistically significantly different here. And so silence and the blue, we see those levels are about the same, but there's a much more dramatic difference for the introverts on those silence and television conditions. And so when we look at this, this is exactly that idea of the effect of one independent variable, and in this case, that's the silence and the television. The effect of that one independent variable depends on the particular level of the other independent variable. How much silence versus television on in the background affects you for your reading comprehension depends on whether you're an introvert or an extrovert. And so just that's the idea of what an interaction effect is. And it really helps sometimes to draw these out because we can imagine this is look the kind of pattern that we see in this graph with one bar going down really far and the other staying the same would be a really traditional way that we could look at that pattern and automatically say, okay, there's an interaction here. If there wasn't an interaction, we would see the exact same pattern for both. And so we might see in that case, maybe the introverts did a little better in silence than the extroverts. So the bars, the blue and the orange bars on the left look exactly the same. But now let's picture that the blue, that looks exactly the same as what would be in the television. And so we see kind of the duplicate of what's under silence right now. Imagine we see that for silence and for television. So we have the same pattern between introverts and extroverts for silence as for television. In that case, with that kind of a pattern, we would say there's no interaction here. There's a mean effect. There's a difference on one of our independent variables, but these two things are not affecting each other. But here we can see this pattern shows that we have an interaction. The other kind of graph that I'll show you is when we have something like a line graph like this. And so we can graph both of our variables on the same chart, essentially. And what's important to take away, and I'm not going to get too much into what this example means or what, what's being represented here, but the important part when we're looking at a factorial design, we have more than one independent variable, and we're looking at a line graph like this. The important thing to remember is that interactions are going to intersect. If we have a mean effect, we're going to see parallel lines. And so that's the real important thing to keep in mind when you're reading papers, when you're looking at graphs and figures in papers that you might be reading in scholarly journal articles, things like that. You want to pay attention when you're looking at these line graphs. If you're seeing these lines intersecting, you know that you're looking at an interaction effect. And again, we can add independent variables here. The more independent variables, the more complex the study and the harder the results are to interpret. It's possible to get three-way and four-way interactions, but we're not going to worry about these. We're going to focus on just these situations where we have two independent variables, and the most that we're going to have is just this interaction between those two variables.